Hello everyone, thanks for joining me in my presentation about Apache Spark 3, NoSQL, Spark SQL, ETL, what's going on there. In this talk, I'm going to introduce you to our brand new Apache Spark 3 support for Couchbase. My name is Michael Litschinger. I work as a software architect for Couchbase on the SDK and connectors team. And yeah, let's get started. So what are we going to talk about today? In this session, first, I'm going to share a little bit of background information about how the ecosystem evolved over time, where we are now and how we came into that spot. And then, of course, what's new in Spark 3 with our new Couchbase connector. And then at the end, we'll jump into a demo where you can see the RDD support, the Spark SQL support, everything you're going about to learn, you'll see that in practice. All right, so how did the ecosystem evolve over time? If we look back into 2015 and earlier, so if my mind doesn't get me wrong, I think Apache Spark started in 2012, around that time frame, when it reached I won't say critical mass, but more and more users, we understood that we need to provide a connector to connect with Couchbase. So in 2015, right around the time where Spark 1.4 got released, we released the first version of our Spark connector in version 1.0. And just for you who maybe have been around for a longer time with Couchbase, that's right when we also introduced Couchbase Server 4.0, which was the first version that shipped Nickel. So the query service with Nickel. Previously, views were the primary mechanism to get secondary indexes in addition to the key value access. So this is why you'll see in the older Spark connectors a heavy focus on views, and then in addition to that, support for Nickel queries. And then in 2016, Spark 2.0 was released, which was a big milestone for the Apache Spark project. And at this point, we were starting to match our version numbers with the Spark connector. So we released our connector 2.0 series, which aligned and compiled with Spark 2.0. And that was around Couchbase Server 4.5 in time frame wise. And then at this point, we were tracking Spark releases. So 2.1, 2.2, 2.3, 2.4, and matched it up with our connectors. Then in 2020, Spark 3.0 got released right around where we released Couchbase Server 6.5. And this is also the time frame where we were actually preparing for 7.0, integrating scopes and collections into the SDKs and shipping our SDK 3 API layer. And so bringing this all forward into this year, 2021, Spark 3.1 was released. And this is where we, a couple weeks ago, shipped our Couchbase connector with support for Spark 3.0 and 3.1. Right? So we ship both at the same time with different artifacts. And this one comes with first-class support for Couchbase Server 7.0, analytics, everything you'll see in a second mentioned here. So looking at Spark between Spark 2.0 and 3.0. So in Spark 2.0, the highlights really were the unification of the data frame and the dataset API. Previously, Spark started with RDD only, then they added data frame support, then they added datasets, and then finally in 2.0 they unified it. They added Spark Session, created a native SQL parser, and for us as a database vendor, the data source v1 API got a couple of enhancements that weren't present in the 1.x series, which provided a good enhancement, but there were still many things to be desired. So fast forward to 3.0, with 3.0 highlights being the adaptive query execution, ANSI SQL, dynamic partitioning pruning, and many more. Again, for us, the main focus was on the data source v2 API, which has been developed along the 2.x series and really got more enhancements with 3.0. And the important part here is it's still evolving. So there are more things planned in Spark 3.2, which we are also going to adopt once it's released. So lots of progress in the new data source API that we are consuming. What changed on the connector side? The main change from an internal perspective is we moved the Spark connector from using the Java 2.x SDK to our brand new Scala SDK. So because Spark is written in Scala underneath, and we have a first-class Scala API available, we moved the whole underpinnings of the connector from Java over to Scala, which makes the integration smoother and provides a better experience overall with regards to different deserialization types, serialization, etc. Also, just a quick plug here, we also released the Kotlin SDK in developer preview. So it sounds related to Apache Spark, but if you want to check it out, you can go to our website, you can go to our forums, and we would be happy to see you trying out the new Kotlin SDK, which is currently in developer preview. Now, all of these SDKs, both Java, Scala, and Kotlin, sit on top of the core infrastructure called Core.io, which get pulled in as a common dependency. And so you can be rest assured that every development, all the bug fixes get automatically sent to the different language bindings, because most of them actually happen into the common core infrastructure. And it allows us to speed up development of further components. So we looked at Spark, we looked at the connector, and let's finally look at what changed on the server between those couple of years. So going from Couchbase Server 4.0 to 7.0, as you can imagine, is quite a big shift. We shipped so many features in that time frame. I had to write it all down to figure out how to fit it on a slide. So between 4.0 and 7.0, we added 3 services. We added the analytics service, which is quite important for Spark actually. We added full text search and we added eventing. And then in addition to those net new services, we added ephemeral buckets in addition to Couchbase buckets, so they are fully in memory. We added scopes and collections to the server and to the SDKs. The key value API got sub-document access, so you can not only manipulate the full document, but you can manipulate parts of it. And also Query, Nickel, and SQL++ for analytics, they all got enhancements over time, right? New features in the individual services, not only net new services. So this is where we are right now with 7.0. And the big feature, and this is why it's marked as bold here, are scopes and collections, because scopes and collections below the buckets really redefine how you can efficiently build applications on top of Couchbase Server. And we had to make changes to all kinds of APIs, not only the SDK APIs, but our connectors, so that you can use them as a first-class concept and not as an afterthought. So what's new? What has changed with our new major version of the connector with Spark 3? So in the early days, also with the older SDK, Couchbase Server itself did not have role-based access control. So what you would do in the past is you would create a bucket, and then you would specify a password for that bucket, and this was your way to connect to it. Now with Couchbase Server 5.0, role-based access control was introduced, and we added it to the old SDKs, but with SDK 3, role-based access control is the first-class concept, the only way to authenticate. So this is now reflected in how you bootstrap the Spark connector as well. Also, bucket scopes and collections are now a first-class concept in addition to the bucket that we had before. And you can configure those either implicitly via a configuration or explicitly via a case class called keyspace, which we're going to see in a second. That's very helpful, both for defining it in an implicit way, so it's very convenient, but also overriding it on a per command basis if you need to. And then the other thing is that, as you maybe know if you've worked with Spark for a little bit, is Spark only allows you to provide configuration via string properties. So you have a key and you have a value, both are strings, which makes complex configuration of the environment a little bit tricky. Now in SDK 3, we greatly enhanced the decoding mechanism for string-based properties, not only for Spark, but also for system properties, connection string, etc. And we are utilizing that functionality inside Spark, so you can configure many parts of our environment through string configuration, as we'll see on the next slide. So here is a configuration example. We are creating a Spark session. We are using the local master, so we are running in our IDE, and then we give it an app name, and this is where the interesting part starts. So all of the properties start with spark.couchbase. They can be provided either through the configuration in your code, or when you run it on an actual Spark cluster, you can provide those properties when you are submitting your job as well. So you're passing in 3 required parameters: the connection string, the username, and the password. Here in our case, we are connecting to localhost, and we're using administrator and password just to illustrate the use case. of course, you would use your role-based access control credentials, and that's the way you connect to it in a secure way. There's also the possibility to configure TLS, transport encryption. Now, then you'll see something called an implicit bucket. You don't have to set it, but you can. So if you're only working in one bucket, if you set the implicit bucket to something like traverse sample or your bucket name, then you don't need to specify it with every operation, which just makes it more convenient. And the last configuration here actually configures a property on the environment. So if you've used the Scala or the Java SDK before, there is a thing called a timeout config, and it has a property called kv timeout. And we set it to 10 seconds. Now, the properties here are going to be extracted, exploded, and then the builder APIs internally are called on the environment and configured. So this is not a special property, but in the same way, you can access all the properties that are part of the application environment. So now that we talked about the configuration, the next concept or the lowest level concept is the RDD in Spark. It's not as common anymore because most people actually utilize Spark SQL because it's more convenient, but the RDD API really allows you to get to the lowest level and also give you the most flexibility, right? So you can use it to read and write data out of Couchbase and into Couchbase from all kinds of different services. You can do an RDD key value fetch, you can do a subdocument fetch, you can use it with query, with analytics, etc. And then we make it available on the Spark context and on RDD transformations. And I'll have one example in the demo that showcases this. And it works for all services except views. So this is one thing that we didn't do. So with Spark 3, we decided to not bring the view support forward because the view functionality has largely been superseded by query, analytics, etc. And we figured that's the right way forward. So how do you read from an RDD? You need to import Couchbase Spark _ that brings all those APIs into the implicit context of the Spark context. And then when you do spark.spark context, you can do something like Couchbase query. You give it a statement string. And then in square brackets, you give it the type you want to decode into. In our case, we just make it simple. We use a JSON object, which is very generic and you can print it, but you can also have your own case classes, etc. That's all configurable. For those who are already using our Scala SDK, we're using the same primitives on top of the Scala SDK, so all the functionality is available in Spark as well. We can not only read from an RDD, we can also write it. So in this example, which is a little more complex, but what you see is we are using the Couchbase get operation with a sequence of 3 get items, which will give it the document ID, so 3 different airlines from our traverse sample bucket. We fetch those, and then we use the map operator to turn it into an upsert operation with an ID and the content, and then we feed it into the Couchbase upset operation, which is part of our RDD context. And here you can see we set a custom key space. We set the key space of foo. So what this will do is it will load our 3 documents from the traverse sample bucket, which we configured through the implicit bucket config. But then we actually say, okay, now the 3 documents, store it in a different bucket. So this is how you can take a couple documents and store it in another bucket very easily. On top of RDDs, of course, there is Spark SQL, and our Spark SQL data sources integrate with 3 different Couchbase services. You can interact with query, you can interact with analytics, and you can interact with key value. So for both query and analytics, you can read data through statements, because query also provides insert and upsert commands, so basically DML. You can also write from a data source, and with key value, you can only write documents. Depending on your use case, you can pick and choose whatever you want. Pushdown of filters and projections are available for query and analytics. We can push down pretty much any predicate that Spark pushes down to our data source. And this is an area where Spark SQL, in my opinion, right now is lacking some flexibility. But this is also an area where they are actively evolving the system. So that's one thing to look out for in the future as they add more predicates, more pushdown, more features that we can push down into Nickel and analytics. We're going to do that going forward. And you can configure those Spark SQL data sources through custom options. So here's an example how you can do a Spark SQL query. So you're using the new format that is available in Spark 3 as well. So you do spark.read, and then in the format, you provide the data source, and there are a couple available. So there is Couchbase.query, Couchbase.analytics, etc. And that's how you say which service you want to use. And then with the option parameter, you can specify custom options. There are enums available so that you get some kind of strong typing. So query options.filter, for example, allows you to set a custom filter. In our case here, we are not using Couchbase Server 7.0, but 6.6. So we run a query on our travel sample bucket, and we set a custom predicate where type equals airline, which will give us all documents in our dataset that are of type airline. And then we can use the data, and we use airlines.write. So we are performing a write operation on data source. Again, we use Couchbase.query, but we store the data in a different bucket. So we store it in the test bucket, and we set the save mode to override. So you can run this code a couple times, and it will use an upset operation internally. And whatever documents are loaded, so the first 5 documents, you see the limit of 5 there, will be stored in a different bucket. Again, this is how you can mix and match read and write operation. You can imagine your read could come from a different data source, or Hadoop, or like some other big data system, and then you can write into Couchbase or vice versa. All right, with that, let's jump into a demo so that you can actually see how it works. All right, so now we are back at our IDE here with my browser as well. So let me briefly show you how my buckets are set up. So I have a couple buckets set up in my Couchbase. Here I'm using 7.01, but you can use any version that you currently run. So we support the Spark Connector supports all the versions that are also supported by the SDK. So we have the beer sample and the travel sample bucket loaded, and then we have 2 more buckets. We have default, and we have a bucket called target bucket, which we're going to use to store documents. So it's just a single node on localhost, but as you know, with Couchbase, it doesn't matter if you run a single node or a 50 node cluster, the code actually works the same. So let's start with RDDs. Again, it's a low-level concept. So let's look at our build.spt file first. So we are depending on Spark 3.1, and we're also using the Spark Connector 3.1. That's all you need to get started. And in our RDD example, the first thing we need to do, very similar to what you saw in the screenshot on the slides, is that we need to start our Spark session. So we connect to localhost, we use administrator and password. Please use your proper role-based access control credentials here. And then we use the travel sample bucket as an implicit bucket, so we don't need to type travel sample all the time. The next thing we need to do is we need to import the Couchbase Spark _ implicit imports. So we get access to all the different APIs on the RDD context, on the Spark context. So this is very similar to what you saw in the slide. We are using Couchbase get on the Spark context, and we're fetching 2 documents out of our travel sample bucket. If I go here and then type .couchbase, so you can see all the different APIs that are available on the Spark context itself. So you can run nickel queries, you can do get upset, you can use our subdocument APIs, you can run an analytics operation, you can run a search query, etc. That's all available. In our case here, we're just loading 2 documents, and we're going to decode them into a JSON object. That's the first example we are going to run. The second example will show you very similar, but not a key-value operation, but rather a nickel query. So we are running a count on our travel sample bucket, and we'll print the number of documents that are stored in our travel sample bucket. And the third example here is where we are reading documents from one bucket and storing them into another bucket. So we are loading 3 documents from our travel sample bucket, mapping into an upset operation, and then specifying a custom key space with a different target. And you can see here, for example, I could also say I want to store it in a custom collection, right? So it's fully bucket scope and collection aware. In our case, we make it simple. We just use the default collection and default scope. So if you only provide the bucket name, it will use the default scope and default collection for convenience. So let's run this in our IDE. Let's make this a little larger here. Oops. Okay, so let's see what's going on here. think actually we should be good here. It's just running a couple commands at the end where the event loop is already shut down. So our actual operation finished. So let's start with number 1, where we are fetching 2 documents. So you'll see here we get success, and our 2 documents, our airline 10 and airline 10642, are loaded and decoded into the JSON object representation, which you could work with later on. So number 2 performs a nickel query. So we can see in our travel sample bucket, there are nearly 32,000 documents. So if we go into our UI, we can see, yep, that's pretty much double the number here because we have the bucket and scopes and collections loaded. So if you look at our travel sample dataset, if we go here, we actually have the default collection with 32,000 documents, which is the one we ran the query on. And then we have another 32,000 documents in our inventory bucket, which is split up in hotel, airport, airline, route, and landmark. So this is why the full document number is different from our default scope that we're using in this case. So this is also something that you might want to look out for when you are using the travel sample bucket with 7.0. So our third example is loading 3 documents and then storing them in another bucket. And what we are printing here is the mutation result, so the result of our store operation. Again, going back here to our buckets, we can see our target bucket now has 3 documents. Going in here, we can see those 3, so that should align 10, 10, 642, and 10, 748. Those were the 3 documents that we loaded and stored in a different bucket. So let's flush it so that we have a clean one for the other examples. So let's go over the Spark SQL examples very quickly. Again, we are connecting, nothing is changed here. We are using the travel sample bucket as our implicit bucket. And then the first example we're going to look at is using Couchbase.query. So we are running a nickel query and we are applying a filter where type equals airline. If you're using collections, you can do something similar where you could say option query options dot collection, and then you could say airline. And in this case, because we know our airline collection in our inventory, right? So we need option query options dot inventory. Scope inventory, which would route the query into the travel sample bucket, but under the inventory scope and into the airline collection. So both would work. If you're using 7.0, if you're pre-7.0, you would use the type usually. Get rid of that, but of course everything works with 7.0 as well. The second example here does something similar, but so we are not printing it. It's just so that you can see it. What this thing will do, it will actually perform automatic schema inference like the Spark 2 connector also did. And it's possible that if you want to have a custom schema, you can use the schema option to provide a custom schema, right? So sometimes, especially if you have a very diverse data set, you don't want automatic schema inference, but you actually want to provide a manual schema. So you can do that as well. And the third example here does something interesting where we are mixing query and key value. So we are using query to load the first 5 entries that are of type airline. And then we are going to write it using the Couchbase.kv data source into our target bucket. And we're using a specific durability option just to showcase, right? So there are a couple options available. By default, it will just store it in memory and will return. If you need a specific majority durability option or something similar with persistence, these are also things we added into SDK3, and now they're available in Spark as well. And then the final example here, the fourth example, shows how you can use data sets. So we're using the as airline property, and then the airline is a case class. So there's a case class with name, code, etc. So you can use your nickel query and turn it into an actual case class, and then you can use the case class and then perform certain operations on it. And then our final example uses Couchbase Analytics. So instead of saying Couchbase.query, you use Couchbase.analytics, and then you can provide scope, dataset, etc. as custom parameters and to perform a query on analytics in the analytics service instead of the query service. So let's run the whole thing and then walk through the results. Fingers crossed that the demo gods are good with us. So while this runs, we can actually start with the first one. So it's running the jobs. So if we look at the first one, we were printing the schema of our airline. So what you can see is we were not specifying any schema at all, right? But if you print the schema, it showed us, okay, our airline has a call sign, a country, an ID, a name, and a type. And this is done using our automatic schema inference mechanism. So the second one did not print. That's the one with the custom schema. You can imagine only having name and type in here, and these other fields would not be present if you're providing a manual schema. Our third call, and you can see it executed there, performing operations, pushing down filters. So you can. I think this is a interesting example. So we are pushing to travel sample, and this is the output of our table. And so the third one actually didn't print anything, but what we did was we stored it into our target bucket. So if we go to the UI again, go into a target bucket, documents. So now we can see the top 5. So we asked to store the top 5 documents in a different bucket. And here we are. So we have 5 documents in our target bucket that previously got loaded through query. And then looking down here to the fourth example where we are loading from query and then we are turning it into a case class. We are extracting the name from our case class and then we filter. We only want to see airlines that start with A and then we print those. So this is why you only see airlines starting with A in that result to mix it up a little bit. And then finally, we have our analytics example where we actually, let's go into the UI here so you can see. So with analytics, we have our airline collection mapped into our dataset. And what we're going to do is perform an operation on our inventory scope with the airline dataset and show the top records. So this is what we're going to see here. So you can see also with analytics, it did automatic schema inference and then it printed the top 20 airlines that are found through analytics. So this is how you can use RDDs. You can use Spark SQL. Again, I'm only scratching the surface here of what's possible. Feel free to check out our documentation, which covers this more, ask questions on the forums, etc. All right. Thank you very much for your time today. I hope you enjoyed the slides and the demo. And thank you very much. Please leave us comments and let us know how you like the talk. And if there are any questions or follow-up with regards to Spark, feel free to contact us on our forums, open an issue on the issue tracker, or just leave us a note. Thank you very much.